October 16th. And Halloween costumes. Kids are picking a different costume choice every week. I don't know how to keep up. Thank goodness I haven't bought it yet. Probably wait till this weekend and draw the line of all the ones they've selected and shortlist them. Going with it. Don't care. Even pull the ones out from last year because I think they still fit those. So we'll see. First off, how about them Seahawks? Back on the winning track, all right? A little bump in the road, no problem. We'll keep it going, though. Hopefully we'll be talking about more wins at our next meeting. I'm definitely taking off work early on Thursday. Make sure I get planted. Clear the loft. Kids, get out of here unless you want to watch. Welcome. Second to last meeting of the year. Yes, already. Had a great year this year so far, so looking forward to 2014. I'll talk a little bit about some of the things we have going for that coming up. But for those of you, I know most of you obviously are familiar with because you're here. So, but for those new members, want to learn more about what we are. We are that EAC community group, that local group that has a big emphasis on the use of Revit, BIM, and collaboration amongst all of our disciplines, really no matter who you are. Even owners, contractors, sub-trades, et cetera. Everybody can come on board for our collaborative learning environment that we like to have every month. A couple little questions relating to our presentation today. So who's been messing around and playing with and using adaptive components in their workflow at all? A couple people? A few people? All right, cool. Good deal. Who hasn't really used them much or never, but is definitely looking for some inspiration because they know a little bit about them, they just don't know how to really kind of push the envelope with it. All right, awesome. You're in the right place. We get some ideas flowing, get people inspired. Because it's definitely a tool that everybody can use. All disciplines can benefit from. Okay, talk a little bit about our executive sponsors this year. Obviously, PPI Group, ID8. And IMAGINiT Technologies, who is our host sponsor for this month, so we definitely appreciate their support in sponsoring this year, and hopefully they're ready for next year. Yeah, all right, let's see. I'll put them on the spot since they're here, right? Don't worry, we'll talk. Our premier partners for the year, Tetra 4D, Canon Solutions America, and Quarry Group. Thank you for their support as well. Big part of our year. As well as, of course, our associate partners, a lot of the firms and groups, organizations out in our industry that really, believe in what we're doing, that like to support us and keep it going. Wood Harbinger, Freiheit and Ho Architects, GLY Construction, Mulvaney G2 Architecture, Leidig Construction, PCS Structural Solutions, FSI Consulting Engineers, Inventrix Engineering, and Integris Architecture. And we all have more information on our meetup site for sponsorship as well. But speaking of sponsorship, talk a little bit about what's coming up for next year so you can start your planning. Whether you want to become a sponsor for us next year or whether you're just trying to plan your schedule for next year. We are in the process of finalizing our sponsorship packages for 2014, so those will be posted and sent out soon. We'll actually send an email out to everybody if they want to link back and check it out, see if it's something that they'd want to do this year, or excuse me, for the upcoming year. We have confirmed that we'll be back here again all next year, so that's a big deal. The Seattle Public Library has been a great host location for us, very centralized. It's been fantastic, and they've actually done a great job at helping us out over the years, for sure. We've pretty much been here for at least 6 years now. So, yeah, so they've been fantastic, actually, and looking forward to coming back again next year. So, speaking of that, mark your calendars. So we did confirm we get the third Wednesday of every month, February through November. Call for presenters. We definitely want... we always like to get industry presentations. I mean, our groups do a fantastic job. The VARs that we have, some of our other sponsors that we have, they do a great job at sponsoring. But there are a series of presentations and meetings throughout the year that we like to kind of gather together our own, and or maybe even give some ideas to some of our VARs about how, about what are some of the presentations that people are looking for out there. So, but if you yourself are considering for your company or organization want to do a presentation, we're all ears. We love to have people feed us information, say, hey, we're thinking about doing this. It's, you know, we focus on, as you know, Revit, BIM, workflow, collaboration are a lot of our heavy topics. Team presentations and case studies, we love those. We like to see how people have been really using them in the different disciplines and share that information so a lot of us can learn from that. The technical presentation and real-world best practices are always fantastic because we always like to get a little granular with the tools to know more about what we can do and dig deep into them. And you know, for this, it's great exposure. It's great exposure for yourself, for your firm, some of the projects you're working on, some of the workflows that you do. You know, who knows what it could lead to? Conversations afterward or a phone call. Hey, I love what you guys do on that. Maybe we should consider working together. So those things actually do happen, believe it or not, from these presentations. If you do have interest, definitely contact the organizers. And the way you do that is on our Meetup homepage. On the left-hand column, you'll see, if you scroll down just a little bit, there's actually an organizers section there. And you can say contact us. Just hit it, brings up a little dialogue. You can actually email all of us, all the SeaRUG board members. And one of us will get in contact with you and talk about what some options are out there and where we have some openings for presentations next year. So even if you have an idea that you just want to work on putting together, or you have a canned presentation ready to go, you know, hey, let us know. And then also the SeaRUG Survey. It's something we've been doing the past 3 years. We'll email, since we don't have a meeting in December, we'll email out a link for a survey for everybody. We really love getting everybody's feedback and you know, let us know about what you thought of what we've been going on this year, topics, maybe things of interest that you want for 2014. We use that to help us organize and outline presentations for the year. We share that information with a lot of our value resellers that sponsor us. If they want to come up with some ideas on topics, you know, so it is a user group so that we want to make sure that your voice is heard about the kind of stuff that you want to hear. The evolution of our group has grown quite a bit over the past years. You know, 6, 7 years ago, we were all, you know, beginners and intermediates or have never touched it but just heard of it. And now we're all like advanced and intermediate users. And the new users are just kind of coming in and learning from a lot of us. So, so let us know where you're at, what you want to know. It really helps outline the year. I talked about this last month, but I figure it was a good opportunity to repeat it. The Building Performance Analysis Certificate Program that Autodesk just recently launched. Actually very cool stuff if you're into wanting to get into conceptual or actually not even really conceptual, but building analysis in your design stages. They have a certificate program now, much like you can get certified for various products. You can get certified with their analysis programs and using the different tools for doing various analysis. They launched it at the end of August. It's for professionals, educators, and their students. I think a lot of it was framed for educational, but it is open for professionals as well. You just go there and there's a link to actually start on it. For the educators, they actually can use that in their curriculum. A lot of them are actually kind of piling it in there, and because you actually have to take little tests along the way, answer little questions, and actually pass all those to become certified. So there is a little bit of homework you have to do. You don't just take a series of, oh, that's how you do that? Okay, I'm done. So you actually have to confirm that you learned it. And this is really helpful because I think, like in my firm, it's kind of hard to just like push people into these things. They got to find opportunities to do it. But now there's like some incentive there. They get this little feather in their cap, and then all of a sudden they can take that knowledge, even though it's a rather, fundamental intermediate knowledge, but that's, what builds up for the next stages of building analysis and using the tools. So I think it's a really good program, and who's taken it so far? I heard that one of our guys went through it, and the last module wasn't completed yet, or wasn't available. It should be now. It's supposed to be done. It's supposed to be available by the middle of this month. The course doesn't take too long, 20 to 25 hours, and the person at my office that actually ripped right through it, he's like, well, since he already was familiar with Vasari and Green Building Studio and Revit, it actually didn't take him that long. He cruised through it pretty quickly. So this 20 to 25 hours is most likely for someone who's very new to those applications. They cover a whole lot of ground in it, so here's all the topics that they cover. So that's always good to know, because just because you want to analyze different things for different situations. So I love it that they actually touch on a whole lot of these fundamentals. Like I mentioned, Revit, Green Building Studio, and Vasari are the core tools that are used. And if you go to the Sustainability Workshop website, that's where you can find information on BPAC. All right, SeaRUG on YouTube. This is just a reminder that we do have a YouTube page. We record these sessions. We're recording this one currently, right?
Yes, sir.
Okay. we've had accidents in the past. We're like, oh, forgot to start recording. But we have 13 presentations that are currently posted up there. We were a little late on getting the last 2 months, so I apologize for that. They are up there now. We had some technical difficulties and also some time issues that kind of got in the way, but they are there now, so definitely go check those out. If you subscribe to our site, you get notified that, that is if you have an account on YouTube, any site that you're subscribed to, as you know, that when there's updated videos that come out, you get notified. We typically like to get them out, get them posted by the end of the month in which the presentation happens, but sometimes that doesn't always happen, so we try our best to achieve that. It's definitely a great refresher for anybody that's come to the presentations and you're like, hey, what did they talk about there? I scribbled down some notes on this, but what was that? We also do lunches, like lunch and learn, brown bag lunches, let it play for the staff that aren't able to make it out. And as far as handouts, we try to put those up as well. There's on our meetup page, on our meetup site, on the discussion pages, if you go to general announcements, you'll see a link for meeting handouts. Then, of course, Autodesk University coming up very soon. I can't believe it's like already almost here. Registration, if you register by October 20th, it'll be $500 less. So if you are in line to go, if you've kind of got that approval process, kind of the gears are moving a little slow, you might want to go talk to who you need to talk to get that moving along pretty quickly if you plan on going to save yourself $500. Of course, website, au.autodesk.com, and AU blog. And also a reminder, I think most people know this, but just in case, I always like to throw it out there. If you're a member on the AU Autodesk University site, it is free. And then you can, if you have a subscription, you actually have access to all the recorded events that happen. So even if you're not able to go, I definitely recommend you get signed up, get signed on there, get your information for your subscription account. If you're not the account holder, talk to whoever's in IT or in your office that handles that. Make sure that you're on it so you can access all those recordings and all that information from past AUs. So it's just an invaluable resource. It's one of those things where people always talk about how I pay the subscription fee every year, but what do I really get out of it besides some technical support, some of these little things? If anything, this is probably one of those biggest chunks of value adds for being on subscription is to have access to all that information from Autodesk University. Okay, prize drawings. As you know, we do this every month. We like to give out a few prizes at the end of the meeting. So first of all, must be present to win. And if you registered, if you're one of the person that registered and signed up, you're automatically in the drawing. I print out all your names and put them in a little box. So I have it over there. We'll do it at the end. Must be present to win, of course. So if you're the +1, sorry, you're not in the drawing. So hopefully when you go back, you'll sign up and you'll register yourself and come in, and you'll be part of the drawing next month. So I guess if you win and the +1, you know, I guess you can argue and fight it out if you want. But so just note that for next month, and that'll help you make your own decisions on if you're able to make it or not. Today's prize, of course, this is what we traditionally give. It's a great gift, 2 Amazon gift cards. So we'll have 2 winners today.
That looks like $2,000.
Oh, it does, doesn't it? 2,000. Yeah. You're like, what? $25? Oh, man. Yeah, that'd be fine. Better be careful about that. All right. So, sponsor recognition. As I mentioned earlier, definitely really appreciate our sponsor generosity every year, not only for sponsoring us financially, but also coming in and helping out with these great presentations that we hear every month. So it's a really big part of it, and obviously, you know, you make this happen, but our sponsors also really make it happen. It's definitely a joint venture on this group. So for this month, I'd like to thank IMAGINiT Technologies for their sponsorship, and Ian Lang, who is a Pacific Northwest sales manager, local in the area, and he will talk a little about what's going on and introduce our main speaker today, our main presentation, Mr. Cowles. Good to have you back. Okay, thanks.
Thanks, Rob. I'm Ian Lang. I'm the sales manager for the Pacific Northwest for IMAGINiT Technologies. I've been with the company now coming up, actually over 5 years. I used to be in the Chicago area, and the company asked me to move out here and kind of take over the sales team and help grow the region. Right now, I am looking to grow the region. I need two more salespeople, so I'm taking referrals for anybody that has anybody that they really want to work with. We're here today to do the adaptive components. Bryan came in from Utah for us to do that. We've got some pretty exciting things happening at our company as well. We have a couple new options for clarity. We're going to do term licensing on that. We also purchased a company earlier this year that does computational fluid dynamics, and it can help with the building analysis side for you guys as well. So if you want more information, please look me up and talk to me about that, and I'll be more than happy to give you the information. And with that, I'll turn it over to Bryan, because it's his show today, not mine.
Awesome. Hello again, everybody. I think this is my 4th, maybe 5th presentation here at the SeaRUG. The room gets less intimidating every time. Here to talk about adaptive components. We started off asking who's using them, who hasn't been using them. It looked probably like a 1 out of 5 has tried to use these or is currently using them, and the rest are not or have not. I also like to get a quick poll of the room. Who is my Revit A people? Architecture. All right, how about S, structure? All right, and M, E, or P? All right, well, the good thing about adaptive components, they apply to everyone. When Autodesk first released this technology in the 2012 product, it really seemed like it was focusing on schematic design, doing panelized structures, doing very interesting patterns onto masses and trying to study that. The Seattle Library is a perfect example of panelized repeating patterns on a very complex shape. As they've evolved these tools, things have changed, and people are starting to come up with more day-to-day uses for these adaptive components because they don't follow the typical flex in one direction or move in this direction logic that the normal parametric family editor uses. All of the components that we place in here understand not only their X, Y, but also the Z direction as well, and the geometry can adapt to all of these directions. So who am I? I'm Bryan. I tend to always have a monkey on my back. Terrible jokes. I always have those. I'm from our Salt Lake City office. I've been with IMAGINiT for 9 years. The next time you see me, that will have 2 numbers in front of it, which is kind of frightening because that is approaching nearly a third of my life that I have been with this company. Before that, I spent 5 in the industry working for a multidisciplinary AE firm, architecture, engineering, a touch of mechanical. And even before that, I actually worked in construction doing framing for multifamily apartment complexes and residential like that. So today's agenda, a couple of just exciting new announcements from IMAGINiT. Last time I was here, I showed Clarity, a tool of ours which is able to automate the production of data from Revit files. Think of being able to push a button and have all your PDFs, all your DWGs, all your schedules or the data in the Revit model exported and put on a server for you. Who here likes exporting sheets? I'm glad I didn't see a single hand go up. We can automate that for you. How cool is that? And we have new licensing options. Previously, it was built very similar to Autodesk's, where you would get a year's worth of service and then the subscription or the maintenance would come up. We now have a new licensing model, which we just call a term license, where you can buy it for a set period of time, perhaps to use on a project, and then at the end of that project, your license is gone. So customers of ours are grouping together and getting a version of this product to work on a project. Great way to get yourself introduced to this technology. Another one is Scan to BIM. This is a product that we have been working on for many years, and it is getting just better and better. And I wanted to actually show a little bit of Scan to BIM today before we jump into our feature presentation, which is the adaptive components. Now, who here has been working with point clouds? Oh, that was a lot of hands. Awesome. So, where am I going? There we are. So first off, working with point clouds is a pain, no matter what way you do it. We at IMAGINiT have developed tools to ease that pain. It's still a time-consuming process, very tedious to get things just how you want, but again, we have made tools to alleviate a lot of that pain. First off is working in this massive point cloud. It's so big, it will drag your computer down to a crawl. So a lot of common workflows is create section boxes in the areas that you're focusing on. Now, wrestling with those grips on the section boxes can be a little bit of a pain as well. So we've just got a few tools to help interact with this point cloud. You see up top I've got my Scan to BIM tool set. And if I say that I would like to make what's called a work view, and I just wanted to focus on this portion of the building, it's actually going to make me a 3D view. Oh, my point, there it is. It's got to load a little bit. It made me a 3D view and automatically cut the section box to match the extents of that box that I just drew. Now, it does use the view range to set the height, so I can just drag that up a little bit higher to get everything that I need. So as you see here, I've got this, this exterior wall. Now, in Revit, there are some tools that allow me to snap to points as we work forward. And it works all right, but it can be a little bit of a struggle. However, how do you know exactly which points you're grabbing and if you are getting the correct points? So I just want to show a few things here. We got a couple tools that make adding geometry extremely easy. So if I said I want to build a wall, what I do here is I pick 3 points on this wall, and they can really be anywhere. So I'll pick one there, I'll pick one down in here, and I'll pick one way over here. Our tool is now analyzing those 3 points, and we're determined they'd make a plane. And then it analyzes all of the points in that plane within a certain tolerance, so you see within an inch. And then it says, what type of wall do I want? What side of the wall are those points? Is it interior or exterior? Now, this is what's really great. I can make a profile wall, which is a normal wall. But let's say our scan is on a tapered wall. It's at an angle. Who here likes drawing tapered walls in Revit? No one. We've actually got a function here called a mass wall. It will build a mass, put the wall onto the mass, turn the mass off. So it will build these tapered walls for us as well. So it doesn't matter if it's vertical or not. So I just hit create a profile wall, and there you see it has now built this geometry. Now there's always going to be a little bit of cleanup as we go forward here. Now we have a bunch of these windows that I want to start focusing on. Now when you're dealing with the existing conditions, you have to think to yourself, how painful do you want this to be? I just want the geometry to be in and accurate. I'm not necessarily going to be scheduling existing windows, right? So I just want geometry there. So we've got some tools here like curtain wall. I just say I want to do a curtain wall, and I can zoom in and just snap to that corner and snap to that corner. Asks me which type of a curtain wall that I would like, so I just go ahead and hit place, and there it's going to go through and help really accelerate the creation of these existing buildings. So now, I just want to show a few more tools. So I'm going to turn off my section box because I want to find a particular area in my model. So now you'll notice because I turned that off, my performance is going to really drag. Okay, where is my curved portion of the building? I think it's over on this end. There it is. So I showed we had that curtain wall tool, and that is primarily for the curved curtain wall. What I can do is also come in, and you see that was for a flat, a straight curtain wall. But I have this curved one right here. So I can actually come up and say, I still want to do an arc wall in this case. Now, I just want to make sure when I do this, I do a selection of points that will define an arc. So notice that I even grabbed in the spaces where the glass was, where we didn't have any points. It identified the mullions had a solid curve to them. So once again, when it comes in, it asks for my tolerance. I can then, in this case, pick that I want to use a curtain wall storefront. And then I can determine and override my top and bottom level offsets if I need to. I'm just going to accept some of the defaults. Go ahead and hit create this curved wall. And you see there, it just threw in that curtain wall aligned right to that point cloud. Now, naturally, I do need to drag my arc a little bit further. I'd want to adjust my mullion spacing of that curtain wall, but again, makes creation of the geometry extremely fast. One other thing that I want to show, I'm going to go back to that original wall that I drew. Because I mentioned when we originally create some of this geometry, oh yeah, a very helpful tip when working in point clouds is this little guy down here, select links, turn that off. So now notice it won't flash and flicker every time I hover over a point in the point cloud. So that's a great little tool down there. Turn off select links. But now I want to see, okay, how accurate is my wall to the point cloud? So we have some tools over here to do what's called a deviation report. How close am I to reality? So I say, let's do a deviation on the face of that wall. And I want to do maybe a 2-inch buffer. Let's see how close we are. I can slide this more or less to see how, get a little bit finer in my report, but I'm going to go ahead and hit update. And what this is going to do is actually color code points according to, let me hide my point cloud now, but you can see there, where's my little grid? Oh, I used the wrong tool. I didn't put the one that automatically puts the little grid on here. So I'm going to just close that. But now, these colors, the pinks and the purples, are good. When we're getting way out into greens or even into dark reds, that means we're plus or minus 2 inches from the actual points. So then you know you've got a really immediate idea of how close you are to reality when you're building your existing designs. Now this will stay on here, but all I need to do is come up and say, let's clear those extra points and we can continue working forward. Now that was a very high level intro to some of those tools. I do want to show one more, a couple of just really nice features that we have. So this, if you couldn't tell, is a mechanical room. Looked great, doesn't it? Sometimes when you receive a point cloud scan, it doesn't have any clear way to present what you're looking at. These points were made with a less expensive scanner that didn't quite have all of the information that that other one did. If you notice, some of those points were green because it was grass, and some points were red because it was brick. These are just all black points, and I can't tell something from the other. I can actually come up here and say, let's look at different color modes that we can toggle through. Now, these are the same color modes available in the visibility graphics, but I just say, let's do this by the normals, which basically is perpendicular to the point. So now you can immediately start to see, okay, that is starting to look a little bit more like a pipe room. So now just a couple last things that I want to show is pipes. We have tools in Scan to BIM to automate the production of some of our MEP components. Right now we support pipe, conduit, rectangular, and round duct. So what I need to do in this case is say, all right, I want to draw some pipe. Now it is going to use the routing preferences of whatever pipe system you've got. So if you noticed, you can see that little guy right there, that's a flange. So I would just want to make sure that I pick a flanged pipe type. So first, I'm just going to do a selection over some of the points of this pipe. Our algorithm finds that, okay, that is about 12.3 inches. So it said we'll switch to this pipe diameter. That can be overridden. And then I'm going to say I wanted to use carbon steel class 150 flanged. I could put insulation on it if I wanted to. And then I can go ahead and hit create pipe. Oh, I must have reset that when I clicked. So there, it just made a pipe for me. Now, I'm going to keep this one selected because this is a key part of our workflow. I now say I need to build more pipe because I want it aligned to that previous pipe that I had. So now, I'm going to select a window of points for that pipe. Go ahead and hit create pipe. Now you see it doesn't actually clean the corners, but all I need to do is come up and say, let's do a trim between there and there. And again, as long as your pipe type is using the fittings that you want, I see, oh, well, that wasn't quite, so I'm going to switch to a long radiused elbow. And there you have it. Now, some things that are pretty sweet is look at this. It sees that this pipe is sloping, so it made it a sloped pipe. Pretty impressive how our developers have made these algorithms to figure this type of stuff out. So that's a really quick look at Scan to BIM. Naturally, you saw me present 2 tools out of like our 30 tools. So if you're interested in more, get in touch with us at IMAGINiT. It's a really powerful technology. A lot of our customers are absolutely loving it. So, on to the main presentation. Adaptive components and their real-life uses. What is an adaptive component? How can we use them? What types of templates, when we're building the family, can we use, and what's the differences between them? They do have oddities and nuances that you need to be aware of, and how points behave, and why they are not adaptive right away, and what's the difference between a placement point and a, I'm forgetting what it's called, shape handle point. And then we'll actually build a couple components. I want to be in the software as much as I can. Oh, forgot to mention our utilities. These are free to our subscription customers, but also available for purchase from our website for a very cheap price. We have some great tools. One is an Excel import and export. Dim text update and concatenate are a couple of our new tools. This slide is actually a little bit out of date because we actually released another tool, which is our BIM, or our Revit link fixer. Has anyone ever opened up a Revit file and none of the links are there? We've got a tool that I say, here's where they should be, here's where they actually are. And it will resolve all of the links before you actually open the file. Awesome tool, great tool. And then I mentioned WorkShare. Being able to automate the production of our common file. So adaptive components. I mentioned earlier that this was originally used as more of a schematic design. Let's make very panelized, patterned skins for our buildings in the massing editor. But a couple of quick things, just being able to quickly establish a few points for a roof cricket and not using the nice but extremely frustrating warped slab tools, right? Sometimes they're nice, sometimes I just want to pull my hair out. A timber connection, being able to just wrap a steel connection around some pieces of structure. Complicated structures that are following irregular shapes, and we need a profile to sweep around in X, Y, Z, weird angles, weird directions. Has anyone tried to do a groin vault in Revit? Adaptive components can work great, especially because to build that groin, I basically pick the 4 corners and establish a height, and that's just a parameter. It will build all of the arcs, connect them in there for me. Who here has tried to do mechanical roofing curbing? Now, it's great if the roof's flat, right? But when the roof is sloped, you can no longer use the hosted profile tool in Revit. The thing that's odd is if you put it on there first when it's flat and then the roof slopes, it works. But if the roof is sloped first and then you try to put it, it doesn't work. Adaptive components can do that as well. You just create your points and they'll sweep around regardless if the roof is sloped or not. Window arch trim. You know, being able to just quickly throw in these arcs regardless of the window size. Who here's tried doing arcs in the regular family editor and have moderate success? They can be challenging. You can get them to work, but they can be a little more challenging. If you use an adaptive component, they become a little bit more easy to use, a little bit more flexible. So where do we start? Which templates do we start with? Well, there are 3 templates you can choose from that support adaptive components. The first one is the curtain panel pattern-based, which, as you would think, is probably to build a curtain panel. Although it's kind of funny, it will work just the same as the generic model if you switch it in the category area. There is the generic model pattern-based, and then there's the one that's just called generic model adaptive components. Now, again, the curtain panel template can be used as a normal adaptive component, contrary to its name. Just be sure you can switch it to generic model when you get there. So what's the difference between a pattern-based one and a non-pattern-based one? Well, it is all about how much control you want. The pattern-based ones will give you a set number of points that are your adaptive points or your placement points. You can add more points if you want, but for the most part, you are locked into the amount of adaptive points that you have. Now, you can change your pattern type in your properties, and we'll take a peek at that really quick. So first, when we go up and say we want to create a new family, you see I've got curtain panel pattern-based, and I've got generic model pattern-based. Notice they look pretty similar. So I'm just going to go ahead and open this one up. Now again, as I mentioned, they are kind of locked into, this one's got 4 adaptive points, and it's for the most part locked into this orientation. But I could grab it and say, in my properties, I want this to be a hexagon shape, or I want it to be an octagon shape. And now you see it's giving me more of these points that I can start to work with. Now, they are not locked to this grid. So notice I can kind of drag one of these up and kind of move it around, although I am locked to the number of these adaptive points that I have. As we go forward, you'll get what I mean by adaptive versus non, and so I'm just going to go ahead and close that. Oh, one more thing, you can also, if you select the grid, notice you can change and modify your default spacing. If you're working on something much bigger or much smaller, you can adjust this right here as well. Let's just go ahead and close that. Okay, so pattern-based, what are the pros? The points, the lines, and the grids are not static. and they can be modified. So you saw I moved the point. I can adjust the lines. Although I'm locked to 8 points. Changing the tile pattern in the grid system will change the amount of points that are provided. So if you know you're building an adaptive component that's going to sweep around a window, just start with a 4-point family. If you're going to start sweeping it around something else, you can start with a pattern that gives you the number of points you need. It gives you a starting point, a little bit of this structure, this skeleton. You'll hear people call this a rig. The cons are additional adaptive points cannot be added. Also, renumbering your points is not allowed. And again, we'll see what these mean when I actually get into the build the family. When we create these adaptive components, they have to be picked in a very specific order to work. Again, another con is the shape handle function is not supported in these as well. So the generic model adaptive, this is the most flexible type. You can really do what you want, how you want, when you want, but this one you're essentially starting from scratch. You get 3 reference planes, X, Y, and Z. All points, lines, other reference geometry must be added by you. So this is the building the skeleton portion. Not too far off of building a skeleton in the normal family editor. You want to start building the structure of how your family is going to work in here. So the pros are, it's very flexible, can fit your very specific needs. If you need more points, less points, the amount of points can be infinite. I wouldn't recommend putting that many points in it, but hey, you could. Points can be renumbered after placement, and that one's a big key here when you're working with your family, and we'll see that in just a bit. Levels can be added, which essentially levels become horizontal reference planes. They don't transfer to the project. They're not going to do anything goofy. They're just additional ways to add in reference planes. The cons is it's an empty template. You're starting from scratch. And all of your rigs or the structure of the family needs to be built manually. So let's start our adaptive component. So first, obviously, you start with your template. Then you need to build your rig. So if you've used the normal family editor, this is the equivalent of building some reference planes, putting in your dimensions and creating some things like that to drive how you want this to look. You actually cannot place an adaptive point. You have to place a reference point and then tell it that it's adaptive. And then that's where you need to just determine, is it going to be a placement point or a shape handle point? And again, we'll get into some of the specifics there. So, lines, arcs, and splines. You can use model lines. You can use reference lines. What's the big difference between them? Well, model lines, they'll work almost the same. You can create forms from them. You can use them to drive other forms. You can dimension to them. But they don't provide the additional reference planes. So if you know when you draw a reference line, you get the line, you get a vertical plane, a horizontal plane, and then 2 vertical planes at the end points of the line, right? Everyone know that? Unless it's curved, if it's a curved line, you just get 2 reference planes at either end of the curve. And that's where reference lines come in. Now, reference lines also do not get what's called absorbed into the form. So that could be another reason to use reference lines, is if I use these lines to make my form, they actually get absorbed into the form. So if I had 2 forms that were sharing the same edge, and I used this line to make the edge on the left, well, that line is going to be gone if I try to make the form for the right edge. Both can be divided, both can host points. It's all just a matter of when you want certain things to behave. Now, hosted points. Hosted points, all points are hosted on something, whether it be just the reference level, whether it be the vertical reference planes, whether it be on a line, on a surface. They can be hosted somewhere. Now, depending on what they're hosted on is the dimensional options for how the points interact with the shape. I found that hosting a point on a line provides the most flexible options. And we'll kind of see this as we go forward. So I'm not going to read all of the options down below. Thankfully, this is being recorded. You can check it out. But you have all of these options. Non-normalized curve parameter, normalized curve parameter, segment length, normalized segment length, chord length, angle. I mean, they could have used a little better names, but they all work pretty well, and it all depends on the situation that you're going to. So let's build some stuff. Enough PowerPoint. So first, let's take a peek at how a adaptive component family behaves. So first, I've got one that I'm going to go ahead and create really quickly. So I'm going to go into Family, pick that I want to make a generic model that's adaptive. Goes ahead and starts with here, get my 3 planes, 2 verticals, and my Z axis. To our Canadian friends, that would be the Z axis. So now I just come up here and pick that I want to place a point. So if you noticed I had the world's ugliest pergola back here, I want to sweep something around this arc. So a key point is identifying how many points we're going to need. This is one of the drawbacks of adaptive components. If you say it's a 5-point adaptive component, you have to pick 5 points, or it won't work. It won't finish it until you pick that last point. And there's no way to say, I want this family to be a 4-point, but it could also be a 5-point, and also be a 6-point. That would have to be 3 separate families, unfortunately. But just getting a little bit of an understanding of what we're doing. So I'm going to place a couple points. And notice I didn't even care where I put them. This is really nice. You probably want to be a little bit more precise than I was, but these are so flexible that you can change things after the fact. You can let the project drive this stuff. But I do want to now say that these points are adaptive. This is going to give them their neat qualities, that they are adaptive components. Now, by default, they get turned into what's called a placement point. That means I have to click everywhere I want this point placed. So if I wanted to have like a doorway with an arch top, and I only wanted to pick the corners of the door, I would make 4 of my points adaptive, and then that arch top point in the middle, so let's say it was this one, I would make it a shape handle point. Notice it was now 1, 2, 3, 4. So these 4 are the ones I'd have to physically click in the model. That 5th point is going to be determined probably by where 2 and 3 are. So I'm going to undo that because I now want, okay, 1, 2, 3, 4, 5. Although let's say I was just running through and I said, all right, I want those adaptive, and I want that adaptive, and I want that adaptive. Whoops, got a little fast. Make adaptive, make adaptive. So then I realize, maybe a little tough to see, those are a little out of order now. It is very important that these are in the correct order. This is why using this generic model one is more flexible. I can renumber these, and you don't have to do that neat thing in Revit where you have to change it to 1.1 and then change the other one to 1, and then you can make it to 2, right? If I say, no, this one needs to be 4, it renumbers that one to 5. It does some assumptions for us. Sometimes it works awesome, sometimes you just have to keep renumbering until it works for us. So now is when I come in and start driving my geometry. So I'm going to use a reference line and start connecting these. Now I want to show a couple things. If I draw one line segment, snapping point to point, I highly recommend 3D snapping is turned on. I'm going to go point to point. And I'm going to hit escape once and then draw from point to point. Oh, missed it. Sorry, undo. Point to point. And notice that time I didn't hit escape. Just notice how the functionality differs. I hit escape on that one, but it still tries to connect them all endpoint to endpoint. So just be aware that it tries to keep them all connected. Now you can tab through and select individual entities here. So then you'll come in and say, I want to draw model lines, and I'm just going to make a simple profile, but I'm going to set my work plane on, right, there we go. So the trick is really tabbing through and making sure that you're on your correct planes. Planes become a very big issue. Oh, whoops, did I want the dimension dumb thing. So now, if you're familiar with the massing editor, The adaptive component family editor uses the same engine as the massing editor. It is a lot different than the normal family editor. So you have to create your sketches and your other referring geometry first. Then I say, that is my profile. That is my path. Now I want to create the form. And you see it just swept that profile along that path. So I could go into a whole how the massing editor is different than the normal family editor, different when it comes to extrusions and blends and revolves and sweeps. Not enough time. But notice now, these points drive that path. If I just grab it and move it up or slide it over, I can do whatever the heck I want to this thing. And that profile is going to follow and keep through all of those points the whole way across. So, that said, let's go ahead and load this into our project. So when you bring it in, what the heck is that thing? Well, it looks exactly as you left it in the family editor. Now, a key here is view control and understanding where exactly you're snapping to. A big recommendation of mine is grab an object and type hi. Hi. That's isolate that element. If you didn't know that, that's a great little tip. Just type hi. So now let's say, let's do a component. Now you want to make sure that you're snapping to these specific points that you want. So there's 1, 2, 3, 4. Notice it still hasn't finished it, but once I click this last point, boom, now it's completed. And it still looks terrible in my preview there. But there, I just went boom, 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 boom. It swept it around all of those points. So let's look at a different thing that we can do. That was all in one plane. Not too difficult. Maybe that was a little impressive. But let's say I had generated a 3D frame of some sort using the massing tools, using AutoCAD even, using SketchUp. Boo. Yeah, that's a very bad word sometimes. It's a great word, but can also be bad. So let's say I had a very fancy entry to my awesome pergola, and I want to sweep a structure around that. So I've got one here that's my 6-point tube. Now wait, that's a hexagon. Why would I pick a 6-point tube? Well, I want it to close 1, 2, 3, 4, 5, and then that 6th point closes it. Following me? Well, you could build it closed. I just like the extra flexibility. So again, you want to make sure you're snapping to the correct points. So notice I could go up, up, and just to be goofy, I am going to send this thing in all sorts of directions. And notice, regardless of which direction I'm going, that probably isn't the direction I would have sent that. But you see, I can go in any direction, any axis I want, and it's going to continue sweeping that shape around. So that's a really quick look at how we can just start with one of these families and start pushing some geometry around. So I'm going to do one more. We'll go there, there. And then you see there's 5. Then that last one will close it off for us. I'm not going to build that whole structural frame, but you could kind of see how much easier this would be than trying to model all of this using the in-place editor or something like that. You see, it didn't take me too long to actually build that family anyways. Place 6 points, connect them with some lines, sweep a profile through it. So let's take a look at some other examples. Let me go here. So let's say I've got a situation like this where we've got a bunch of wood timbers coming up to a nice wood beam, and I want to do some structural connections around these. Now, using the out-of-the-box Revit structural connections, they wouldn't even work here. But what I could do, once again, I do recommend saying hello. Just type hi. It'll isolate your object and let you work a little bit easier in these areas. So I'm going to go ahead and pick my structural connection one. Now this one's a little bit big, but this one is a magical 8-point structural connection. I can just kind of click on the bottom, move up, click around the top, and drive this. Now I'm going to build this one in just a moment and show some of the differences that we've got. So what I can do, I'm going to pick right on the bottom edge. Now the key here is the face that you're looking for, and I'll show you why in just a moment. Notice right there it would get the bottom of that timber, but I'm going to hit tab, and now you can see that it's grabbing that face of the timber. Everyone see that? So I'm going to pick there, head up, pick there. Let me spin this around. There. Make sure I'm on the face. So there is my first 4. Now I'm going to go up. Now you may be thinking, well, you're not being very precise at all. No, I'm not. I will be in just a moment. So I'm going to pick right here. There. There. And my last point would be right there. So there you see it just swept that shape all the way around. It looks like when I built this family, I had my extrusion going the wrong direction. I can fix that pretty easily. But now I want to show, I talked about in my PowerPoint back here, all of these different options: measurement type, normal parameter, segment length, normalized. This is where these start to come into handy, because this is hosted on that line or that edge of the beam. When I jump in, I can say, okay, point 6, I'm hitting tab to select it, and point, I think that's 1. I want these to be driven by a length, and that length should be 2 feet. And now it's pulling the information from that edge. That's why I was saying make sure you're getting the correct edges, correct faces, so things can start to flex and change how you want. So I can come over here and say, all right, those 2 points also need to be a length of 2 feet. Oh, that was odd. I wonder why that one went way down there. Interesting. Well, I'm not going to try to fix that now, but you can kind of see how these are driving. So that's 2 feet. And this one here, 2 feet. Interesting. Not sure why that's doing that. I must have picked the wrong face, to be honest, and that's why it's not functioning as I saw. I can come up here and hit Show Host, and then say, let's invert that. Oh, maybe not. It's trying to pull from this end, is what's happening, as you can see that. So I would need to do a little bit of readjusting on that point, but I can, again, adjust things like that pretty quickly and easily. So let's build this family. Let's do it right now. So I'm going to jump up and say, let's go to New Family. Got about 20 more minutes, so this is all right. I'm going to make an adaptive component. And I'm now going to start with my 4 original points. There's my bottom. 1, 2, 3, 4. I want those points all to be adaptive. Now, go to an elevation and grab them all, making sure I have all 4 points. And I'll copy those up. Well, not 10 feet. 5 feet's fine, however like that. So now you see I have this series of points there. Now, notice 1, 2, 3, 4. I want this one to be 5. So I'm going to renumber 8 to 5, renumber 7 to 6. That one's 7, that one's 8. So now it goes 1, 2, 3, 4, 5, 6, 7, 8. Now comes the point where you need to start generating your forms. So I'm going to do this. Now this is a pretty nice tool. Make a surface from closed loops. If you know you're going to make a surface after this, you can check that. I'm not going to. So I'll just I want to go from 1 to 2. Oh, I'm going to back up because I forgot a key point here. When you do this, use draw on face instead of draw on work plane. It won't let you go in the Z direction if draw on work plane is selected. So I'm going to say draw on face and go 1 to 2, actually up to 7 to 8, down to 1. And do the same thing over here. There's a line already there, so I don't need to draw a duplicate. If I were using a model line, I would have to draw more than one line because, again, model lines get absorbed into the form. If they're sharing an edge, use a reference, not a model line. So then I just come and say there, whoops, there, let's create a form. No, that didn't do what I wanted it to there either. Let's try this again. Using all these points and those points, create my form. Now it generated an extrusion, or I can make it just a surface. So you've got different options. So I'm actually going to undo that because I want it to be an extrusion. You want the points as well. Create that, make it an extrusion, and then I'm going to make it go that direction. Now, sure enough, I could dimension this, label it, make it my plate thickness parameter if I wanted. Now I'm just going to continue around, create another form, solid. Around here, create another form that's solid. And oh, what the heck, I'll make those all a parameter too. Let's say 1/2 inch or something. Again, I could make those all a parameter. I'm not going to, just to bear us the time. I assume you have a decent understanding of the family editor if you're at this point in your Revit career. So now, there it is. It honestly is just like that. I can load this into my project. And then sure enough, I can go 1, 2, 3. I'm going very fast. I'm following my own rules of making sure you're picking the correct faces and points. 5, 6, 7, and 8. So there you see how quickly you can generate geometry like this that's going to move around. I'm going a little bit slower than I was anticipating, so I'm going to show one more. Let's go HR and bring some of this back. And that is a roof cricket. So if I come up and, no, not a column. Getting a little excited here. Okay, let's do a component. There it is. Oh no, that's not it. Maybe I haven't loaded it yet. So before I actually place this, let's take a look at how it's built. So essentially, this one I started off with a 4-point pattern-based adaptive component. I just used the 4 points because I want to pick the 3 points along the edge that's going to drive the height of the cricket, and then the 4th point, which is going to drive the length of the cricket. Now notice it doesn't quite look like a cricket yet, but remember, this point right there can be anywhere. It's really where I pick that point. So even though you're thinking that needs to be a flat edge there, well, that's all right. Another thing that I did is I created this point. Notice it is not adaptive. It is just a reference point. Now, I mentioned knowing your work plane and where you're at. I also said this point, its work plane was on point 2. So basically now, if you notice, if point 2 moves, that point is going to move with it as well. So that's another little thing that I did as well. So just kind of use some of your typical family concepts of understanding alignments and locks and constraints and work planes. And the last thing here is these reference points, because it's hosted on point 2. One of the properties of this is the offset. That's how high above that point this needs to be. So I actually took that and made it a parameter called rise. That's my rise parameter. As you see, I did a dimension from point 4 to point 2. This is our run parameter. I also added one more property that is slope. Slope is 6 inches. Now naturally I had to make a formula. I know slope is rise over run, so doing a little bit of algebra and switching fields and moving one to the other, I know that rise equals run times slope. Now wait, what's this divided by 1 foot? Well, sometimes you just have to do this in Revit. I'll show you why. Run is a length. Slope is a length. If I times a length by a length, I get a area. My rise parameter is a length. So when I do that, it will say, one of our favorite errors in the Revit family editor, inconsistent units. So that's where I have to say, okay, my formula is run times slope, which gives me an area, but if I divide an area by a length, I'm just going to say 1 foot, cuts off the foot squared and just leaves it at foot, right? Who thought you would be using 8th grade geometry inside of the Revit family editor? So there you go. As soon as you divide it by 1 foot, it makes the consistency between the units happen. So there we have it. Let's switch back to our project. This is just a flat little slab I put in. This could be sloped. It could be, whatever we want. So I'm just going to say, let's do a component. Let's use that. Where the heck is it? This is another way to get your family in. You can just drag it from over there. So now, very important you remember the order that you picked. So I had 1 was the end of my cricket, 2 was the middle, the height, 3 was the other end, and then 4 was the length out. So here I'm just going to say there's point 1. Following on that edge, I'm going to say there's point 2, there's point 3, and then point 4 is going to be out there. And I didn't get that correct, so let me try this again. Place on the face. There we go, making sure the top face is the one that I have selected. Again, making sure the top face, what happened previously is I went like that, and now it's getting that edge on the back. Very important here. Just move my cursor just a little bit. There. There. Oh, well, this was just working lovely about 2 hours ago. And now it doesn't seem to want to do that. Well, I'll try it one more time. So here, 2, 3, and it still looks like it's not going to do exactly how I wanted it. Well, I'm missing something there, obviously. I can provide you with this family content if you need. But that's kind of the concepts of building this information into our components. Now, a couple more things I just want to show in the actual component family editor. I'm not going to be building anything specific. I just want to show some things that can be done. Say another new family. And we'll go to another generic model. So I'm going to start by putting in some points. 1, 2. Next, I'm going to be a little bit more precise with this one. So I'm going to start with just 1, make it adaptive, and copy it. And here I'm going to make sure I'm copying it in a straight line. And then I'm going to make sure that I copy those in a straight line. So there I've got 4 points. This can be done again with model or reference lines. I'm going to just kind of route around here. There is my overall shape. But then you can actually grab, if you use tab, the individual reference lines, not the whole selection of them, and I'll grab that one as well. There's some tools up here that allow us to divide paths. So if I say divide, I can pick how many points I want. So it's adding a lot of reference points along this reference line. Now this is useful if you need to do a differing spacing across a length. So let's take, for example, that structural connection I had. If I wanted to throw in bolts that adjust as that also adjusts, I can start to divide the length up. So you'll see these points are things that I can start snapping to as well. So I'm just going to do this with model lines. But I'll say there to there, there to there. Let's connect a bunch of these. Now, all of these are logically tied together. So if I grabbed one point and kind of moved it where I want, or slide it there, you see that we're keeping that 3D relationship across all of these components. So if you're doing a very nice slopey, entry awning into a building, or you're trying to design the world's most unsafe ladder, you can get a lot of different flexibility out of these tools as you go forward. And, sure enough, the tool will adapt to where those 4 points are now placed. A couple other things to show. I did everything I just showed with straight lines. I could honestly keep teaching this topic for another 5-6 hours and still have stuff to go through at the end of the day. So I'm going to delete, not that one, all this stuff. And that too, and that too. And just move this one over here. Make that to 0.1, so I've got 1, 2, 3, 4. You can do splines, through points, arcs, and the adaptive components will work with those as well. So if I say, let's do a spline. That's the one I want, spline through points. I should say this spline tool doesn't behave very well. You want spline through points. So there it can snap to your points. And you just hit escape. So there you've got your spline, and sure enough, this thing can do all sorts of magic stuff. Because it's now following that spline to get things. Works with arcs as well, and arcs are actually a new to 2014 function. Oddly enough, we could do splines last year, but we couldn't do arcs. Doesn't even make sense to me. But now arcs are supported as well. A key is just make sure that this 3D snapping is enabled. Sure enough, you do have to then follow the massing editor and the way that it generates content. So where you draw your next shape and then create your forms, it's ultimately up to you. But again, just trying to give you as many examples of different possibilities that these could be in just an hour's worth of time. So I think that is everything that I wanted to show, with the exception of one thing that I want to I'm going to hide this really quick. Because this was an example that we did for a customer of ours that was building it was done last year, that's doing a tunnel. And they keep getting different profile lines from the civil engineering company for the center line of the tunnel. They tried one way and they got stuck with something and had to adjust it. And they came to us saying, we built this using just in-place sweeps, and every time the civil engineer changes the profile, even a little bit, we have to start over. So what we did is established essentially an 8-mile long adaptive component that's a tunnel. And basically they import their civil 3D profile and they can just kind of pick points along that profile, and the tunnel drops and curves because they used adaptive points through a spline. So sorry for the file upgrade. I thought it was 14, but apparently it was not. So this one is a pretty big stinking tunnel. So notice my laptop comes to a screeching halt because that's like, it's almost a mile long or so. Just to give a quick example. All right, buddy, come on. You know, so as you can see, this is essentially a train tunnel, and it's an adaptive component. Now, some of this stuff in here is not. It's actually several adaptive components that they just trace the same points. Oh, well, actually they traced it once, copied it in place 3 times, and then just said, this one's the outer tube, this one's the inner tube, this one's the track, this one's the little profile. So that's kind of how they did that, so they didn't have to pick 200 points every time. But now, if the profile changes, they just need to identify where it changed and adjust the points, not start over. So again, just giving another just real-world example. This is something that's not an everyday use, like my title of this presentation was, but hopefully that structural connection, the roof cricket example, the curbing for a mechanical system, as you see, they'll follow whatever they're hooked onto, and they're pretty impressive and powerful tools. So, that said, I'm bumping up on my hour, so I'll just go ahead and say thank you. Any questions that
Any quick questions?
running through your mind?
Can we use families in the adaptive component?
Like nest a family into the adaptive family editor? I believe so. But I also have heard that it really weighs these families down. And they're already a little heavier than normal families. So yes, you can, but be careful with it. Make sure that the nested family is a lightweight family. And if you didn't hear the question, it was, can you put nested families into the adaptive family? Good question. Anyone else? That was for the mic. All right. Pass it back to Rob.
All right, thanks, Brian. That was great, man. Thank you very much. So obviously, I want to say thank you to Brian for coming out and doing this for us again. Always appreciate having you. Just on a side note, I had to make a note. If you get a chance, kind of speaking back to our YouTube page, check out Brian's presentation he did last year on stairs and railings. It was actually really good. It covered a lot of the new stair components, and it was really, really interesting. Got a lot of good responses from that presentation last year. So, of course, Ian Lang, thank you again from IMAGINiT. So these guys will be around if you got some questions afterwards. And our next meeting is November 20th. It'll be our last meeting for this year. Oh, I know. Sad. I can see all faces drop. Only one more? Yes. But that's okay because we're going to re-rack for next year, so we'll be good to go. That's about it. And then we'll just do our quick drawing for our two. That's what everybody's really waiting for, huh? Who's gonna? Yeah. The drawing. All right, Ian. You want to just grab 2 out of there.
2?
Yep.
Separated here.
Let's see if our 2 people. What do we got?
Michelle Dang.
Michelle here. All right.
Okay.
And
Judy Coleman Graves.
Judy. All right.
Excellent.
All right. Okay. Well, thanks everybody. Feel free to hang out, and we'll see you next month.